Hello everyone, I'm Zhao from University of Northern British Columbia. Today I will give a discussion on characterization of apparent dynamic stiffness of elastic interlayer materials for floating floor applications. Dynamic stiffness is the key factor to quantify an elastic material's performance and determines the impact on collision performance of a floating floor assembly. And it is also used to predict impacts on insulation improvement of a floating floor. In the graphs over here, the acoustic product represents the black mat over here on the floating floor, on the mass timber floor as a elastic material. The ISO test standard guides the procedure of apparent dynamic stiffness test, and the core part is to determine the fundamental frequency. However, in the test standard, it doesn't specify the procedure to select the fundamental frequency from these spectra that obtained in the testing procedure. And people usually pick the very first peak as the fundamental frequency. However, the frequency spectrum varies among sample to sample. So the very first peak may not always be the fundamental frequency of the system. The steel plate is assumed as a rigid body in the dynamic stiffness test, and in the software simulation, the rigid steel plate has 6 basic rigid body modes and 3 natural frequencies. With further assumption of single degree of freedom movements on the steel plates, as shown over here, the one that moves only up and down is considered as the fundamental frequency. However, in my real work, there are 2 similar mode shapes move up and down, obtained in the same test at 22 and 35 Hz. So the fundamental frequency cannot be determined with only mode shape alone. The test standard also suggests to use a 8 kilogram steel plate as a mass topping. However, the 8 kilogram plate is way heavier than real construction situations. In my work, the steel plates with 3 other thicknesses were applied. 9 of elastic materials from 5 different companies are selected, together with floating of 4 different steel plates. These are the real lab test setups for the dynamic stiffness tests. The plastic frame over here is to investigate the influence of the air boundary condition on the dynamic stiffness of a material. As shown in the graph, the plastic frame doesn't have a strong effect on the dynamic stiffness values comparing to the open air boundary condition situations. With the reducing of the floating mass, the apparent dynamic stiffness measurement values are reduced significantly, especially for those materials with stiffer dynamic stiffness values. They have more impact. In summary, the mass topping has effect on apparent dynamic stiffness of elastic interlayers. The closed air boundary condition is not a significant factor to be considered as well. In the future, and according to my lab test results, these 3 questions are raised and can be discussed in the future. Thank you.